Okay, let's look at question number 7. So this is parametric differentiation question. So parametric equations of an ellipse are given. These two, alpha is the parameter, and then we have to find dy over dx. So let's find dx over d alpha first, which is minus 13 sine alpha, then dy over d alpha, which is 5 cos alpha, then dy over dx is what? Dy over d alpha divided by dx over d alpha. So 5 cos alpha divided by minus 13 sine alpha. So minus 5 over 13 cot alpha. So that part is done. Then what do you need to find? On this curve at this point, parameter alpha point, so the general point, we are drawing both the normal and this is tangent and the normal. So we are drawing, or we are trying to draw these two tangents and normals at this parameter alpha point, and then we have to find those two equations. What's the equation of the tangent? What's the equation of the normal? So point is alpha, so then gradient is given by dy over dx, no? Gradient of the tangent line. So that is the gradient of the tangent line. M tangent is what? Minus 5 over 13 cot alpha. And the point is this, x value is this, y value is this. So then we can write the equation of the tangent. Y minus 5 sine alpha minus 5 over 13 cot alpha x minus 13 cos alpha. So that is equation of the tangent. Let me mark it as 1. No need to simplify this. They haven't asked us to simplify. No. If you want, you just move the minus 5 sine alpha to the other side and write it in y equals mx plus c form. But just leave it like this. This is enough. Then we need to find what? M normal first to find the normal line equation. Gradient of the normal is what? Negative reciprocal of this one. So 13 over 5 cot alpha becomes tan alpha. So that's the gradient of the normal, and we have to find the equation at the same point. So what is the equation? Y minus 5 sine alpha 13 over 5 tan alpha x minus 13 cos alpha, right? So let me mark it as equation 2, right? So that is the normal line, right? So that is done. Then they say this tangent and normal cuts the x-axis at A and B points. So normal cuts it at A, sorry, tangent cuts it at A, normal line cuts the x-axis at B. Then find OA times OB. So just find the x coordinates of A and B, then multiply them. Then it should be come out to be 144. That's what we are supposed to do. A and B are on the x-axis, no? Then OA distance is the x distance from the origin. OB distance is the x distance or the x coordinate from value at B, right? So now we have to find those 2 points, no? So first let's find A. A is the point where the tangent line cuts the x-axis. So that is the x-intercept. No? So y value is 0. So substitute y equals 0 into first equation. Sub y equals 0 into 1 to find A x coordinate. Right. So what do you get? So minus 5 sine alpha minus 5 over 13 cot alpha x minus 13 cos alpha. So 5 and 5 cancel, sorry, minus 5 and minus 5 cancel. You let me move this to this side. So let's get 13 sin alpha. Cot alpha, let me write as cos alpha sin alpha. X minus 13 cos alpha. Multiply the sin alpha out, you get 13 sin squared alpha x cos alpha times minus 13 cos squared alpha. Then x cos alpha is equal to 13 sin squared alpha plus 13 cos squared alpha. Then x is equal to 13 over cos alpha. Right. So because this is what Pythagorean identity, no? 13 you can take out, then you get sin squared alpha plus cos squared alpha, which is 1. So this is the a coordinate, sorry, x coordinate of a. Right. So this is same as what? OA. You take for the OA distance. We'll take it as the modulus. Do we need to take it as modulus? We'll see if we need distance. No, OA is the distance, so we'll take it as modulus if it is required. Right. So this is the x coordinate of A. Then we need to similarly find x coordinate of y. Sorry, B, x coordinate of B. So for that, you have to substitute y equals 0 into the second equation. B is the x-intercept of the normal. Sub y equals 0 into equation 2 to find x coordinate of B. So 0 minus 5 sin alpha, 13 over 5 tan alpha, 13 over 5 tan alpha, let me write it as sin alpha over cos alpha, x minus 13 cos alpha. Right, now cut the terms, you can cancel easily. You can cancel what? Sin alpha you can cancel. Then move the 5 to this side, you get minus 25, 13, no, minus 25 cos alpha. Let's move the cos alpha also. Then here you have 13x minus 169 cos alpha. So then 13x is equal to 144 cos alpha. X equals 144 over 13 cos alpha. So this is the B coordinate, x coordinate of B. Right. So then we need to do what? OA times OB. So distance, no? So take the absolute value of this point, these 2 points. Then we don't need to worry whether they are positive or negative. No? So absolute value of this OA times absolute value of this one. So then the cos alphas cancel, 13s cancel, absolute value of 144 is 144. Right. So that is the 7th question.